Hello again. This is our second installment of simplifying rational expressions, and we're going to go ahead and start with the first one first, obviously. So this is two terms and this is two terms, but since they're not exactly the same, I can't divide it. I can only divide two terms by two terms if they're exactly the same. Same thing with three terms out of three terms, etc. One term divided by one term, though, I can just cancel out what they have in common. That said, let's figure out how to do this problem. And as I said, I probably went very fast on the last one. It's not because that's the way I teach when I do it, it's just I have limited time to do it, so that's what I gotta do. So what can I take out of the numerator from the first one? What do 2 and 8 have in common? And if you said a 2, you'd be right. But if you stop there, you wouldn't be, because that has x squared and that has x, so I can also pull out an x. When I do that, I've got x plus 4. And what I tell my students to do is check. 2x times x is 2x squared. 2x times positive 4 is plus 8x. Bam! What can I take out of the denominator? I can take out a 3, because 3x and 12 have a 3 in common. Now when I do that, I've got an x plus 4 left over. I'm not done though. Now, this is perfectly legal. When I have two terms divided by two terms and they're exactly the same, it goes away like a bad habit. I've got 2x over 3. 2x over 3 doesn't reduce or simplify. The answer is 2x over 3. Now, one thing I did neglect on my lesson is checking for domain and range, what values I can plug in and not plug in. I'm not going to do that right now because simplifying rational expressions is the most important thing to talk about. But what I basically mean by that is what value can you not plug in for x and not make this untrue, or what's the vertical asymptote. So what value times 3 plus 12 will make the denominator 0? Well, you take the opposite of this and divide by 3, it'd be negative 4. Okay, next one. X squared subtracted 3x minus 10 over x squared plus 6x plus 8. Now I can't take out a GCF, but I can factor into two binomials. And that's what I'm going to do in blue. Positive, negative, positive, positive. X times x is x squared. X times x is x squared. What times what is 10, but it adds up to be negative 3? That's negative 5, positive 3. What times what multiplies to be 8? Maybe I said that one wrong, pardon. What times what multiplies to be 8, but it adds up to be 6? 4 and 2. Nothing cancels. Let me just make sure. I knew I was wrong. That's a 2. I said 2 and I put a 3 for some bizarre reason. 2 times 5 is that. Anyways, so what cancels out? These two terms cancel out. And I'm left with x subtract 5 over x plus 4. Now what a lot of students do is they say, oh, the answer is negative 5 over 4. Nope. You have to imagine that these have parentheses over them, and when you're dividing two terms by two terms, they have to be exactly the same. That is all you can do. You can't say, oh, I'm going to divide it. No. 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 If they're in quantities, it's got to be exactly the same. That's when it's more than one term. Ooh. Okay, first of all, there's something wrong with this one. It's not written in standard form. Now, anybody who might be watching this will say, well, I know how to do this without doing that. That's great. I don't care. My advice is to rewrite it in standard form. Negative x squared plus 16. Yeah, it probably takes an extra step. It probably does, but it's still good math. This factors into a negative negative, x and x, 4 and 3. I can take out a negative 1 from here, and I'm left with x squared subtract 16. I never want my first term to be negative. It just makes it more of a factoring nightmare. This is something called the difference of two perfect squares. It's a difference. There's two terms, and each one's a perfect square. So this factors to x minus 4. Well, sorry, I'm going to rewrite the numerator again. This factors to x plus 4, x subtract 4. Do they have in common? They have the subtract 4 in common. Bam! My answer is x subtract 3 over negative 1 times the quantity x plus 4. Well, not really. Let me erase this previous problem just to show you. Theoretically speaking, you shouldn't have a negative in quantity in the denominator, so just put that -1 on the top. You shouldn't ever be able to divide by a negative, and I suppose the reason is division, very simply stated, is a number of products divided by people. That's my little theory into it, you don't have to quote me. But you can't divide by -1 person, so you always divide by a positive quantity. Now somebody's going to say, well, what happens if x is -5? That's not the point. X is a variable. You can vary it. But you shouldn't have a -1 standing in the denominator when you can easily put it in the numerator. Yeah, that's simplifying rational expressions. Now what we're going to do is we're going to multiply and divide, which is pretty fun. I use a little story or trick that I talk about when I do this. But until that time, have a good day for now. Have a good day for now, pardon me. Goodbye.